This is lesson 5-6 on matrix algebra. So in the last lesson, we introduced this idea of matrices. Remember, a matrix is a rectangular array of numbers. So it's just a grid of numbers, basically. Just like our regular individual numbers, matrices can be added, subtracted, and multiplied. We could also think about dividing matrices, but it's going to be a little bit, you'd have to think about it a little bit differently. So we won't really focus on that in this class. But we can think of it as, we can think of multiplying by an inverse, which we will talk about later. But division, we usually don't use that language when talking about matrices. When we add and subtract two matrices, which is what we'll be focusing on in this lesson, we have to work with matrices that are the exact same size. If they're off by even just a little bit, it won't work. So if we do have two matrices that are the exact same size, here we have two different 2x2 matrices. When that occurs, we just add the individual components. Very simple, very easy. So they've got to be the exact same size, and when that happens, you do really exactly what you'd expect to do. Add the corresponding components together. Now in this example, we've got a 2x2 matrix and a 2x3 matrix. So they're pretty close, but not exactly the same. So we cannot add these two matrices together. They have to be the exact same, otherwise it won't work. So we'll take a look at our quick, relatively simple drill problems from this section. No application here, but we'll be doing some fancier things with matrices later on. All right, so let's consider this problem. So we want to find the sum of these two matrices. So as we mentioned before, the way that you find the sum or the difference is just to take the sum or the difference of the individual parts. So my first term is going to be 1 plus 5, so 6. Negative 2 plus negative 3, which will be negative 5. 2 plus 3, that's 5. 5 plus 3, that's 8. 0 plus 1 is 1. And 3 plus negative 6, that's negative 3. So that's it. That's what my matrix looks like. That's what the sum matrix looks like. So look at one that's slightly more complicated, but these are all meant to be very quick, very simple problems, so long as you keep your cool and you realize exactly what you need to do for these. All right, one more. So find the difference of these two matrices. So let's go ahead and start with our matrix. Once again, to find the individual components, we're just going to take the difference of the individual components. Now notice here, this 2 out front and this 3 out front. We're multiplying everything here by 2, everything here by 3. So to get our final answer, we need to say 2 times 4, so 8, minus 3 times 1, so 8 minus 3. That's going to be 5. 4 minus, let's see, that's going to be 4 minus negative 9, so 4 plus 9. So that's going to be 13. Negative 2 minus 0, so negative 2. 4 minus 6, so negative 2. 6 minus 9, that will be negative 3. And then 10 minus 12, that will be negative 2. So there's our final answer. If you need to write this out individually, if you need to go ahead and write what this looks like with everything multiplied by 2 and everything here multiplied by 3, feel free to do that at first. But I would encourage you, this is meant to be a quick problem. Get to the point where you can do that mentally. Again, for the time being, feel free to do that, but try to work your way towards being able to do that mentally without having to write everything down.